All right, good morning, reviewers. This is my Designing Technology Solutions class, my first period class. It's a class of 9th and 12th graders. And in this class, we study robotics, intro to computer science and technology. Today, you're going to see the introduction of a concussion program that we're going to be coding. It's called the Concussion app. And what you're going to see is my introduction to the project, discussing the process of developing an algorithm using computational thinking, and then you're going to see the start of a lab in which they pair program. The whole point of this project is to put everything together that they've learned about algorithmic instructions and even expressing relationships among variables. So here we go. Good morning, first period. Good morning. Good morning, folks. We have some objectives on the board. They're over there as well. Let's see here. Can I get someone to read objective number 1? Seku.
Explain how sequence selection and iteration are building blocks for algorithms.
Okay, so before we even start, let's get a figure rating 1 through 5. 1 being I don't know anything about these topics, about these algorithmic instructions, and 5 being I'm pretty much an expert. 1, 2, 3, 4, 5. Yeah, what do you think? She says she's an expert. All right, sweet. Okay, number 2. Someone read that. Amity, nice and loud.
Create equations with 2 or more variables to represent relationships between quantities.
Among quantities, very good. And so, Amity, if you were to give yourself a rating 1 through 5, what would you say about creating an equation with 2 or more variables? Amity, what would you say you are? 5 is highest.
5.
And he says he's a 5. Go ahead and put your figure rating up. Hopefully a 5. Everyone? Just humor me.
A 6.
Very good, thank you. So that gives me a good idea of where people are at. So we're all going to be either 4s or 5s by the end of this project. So let's begin. You already have your warm-up, and you've been filling it out. Excellent. Write your name, period, date on it. We're going to actually hand this in before the end of the period. So do not lose it. This is not one of those warm-ups that you're just doing just to do. You need to hand it in at the end of the period. Solve for C, given the following variable values, right up there. Take it.
It says solve for R.
Oh, oops, typo. Solve for C. Solve for C, given the following variable values. And then after that, for number 2, we're going to get into the relationship among these variables. Go ahead and answer those questions A, B, C, and D. Check your work with Cameron. See what you guys got to say. Does everyone understand questions 2C and 2D? What it's asking you? Yep.
Okay.
How does V affect C? So you think about V, if you plug in a number for V, how does it affect C? Maybe, maybe not. We'll discuss that, Seku. So Seku asked, well, how does V affect C to V? What does that mean? And then he said, isn't that the same for all the other variables? I wonder if that's the same. Natalie, let's take a look at V and B. What's the difference between V and B in that equation?
V doesn't have a coefficient, but V does.
What's that word again?
Coefficient.
V doesn't have a coefficient and B does. Ryan, what is B's coefficient?
2.
What is M's coefficient? Folks.
5.
So which one has a greater effect on C?
M.
M. We'll look into that today. So let's begin. Concussion factors. Folks, raise your hand if you've ever had a concussion. Oh, Alexis, explain.
It's when like you hit your head and your brain hits your skull.
And how did you get a concussion?
I was like snowboarding and skateboarding.
Oh, you got 2 concussions.
Well, I've had like several.
Several concussions. Boxers get concussions a lot. So do snowboarders and skateboarders. Let's take a look at this video.
This is a very widespread problem due to accidents, injuries in sports and the military. And a big challenge is that almost 90% of the concussions remain undetected. Another problem is that the existing tools are very cumbersome. You have to go to the physician's office, go through a variety of tests, and you often don't know until the person is concussed until much later. So our goal was to develop a tool that can address some of the shortcomings of existing tools, including accuracy and prevention of cheating on a test. It happens that athletes cheat on these tests to get back into the game as soon as possible. So with the help of the medical team at Notre Dame, we were able to perform tests with the boxing teams on campus, the Bengal bouts in spring and the Baraka bouts in fall. So during the test, the athlete speaks into a microphone on a tablet device, and the speech is analyzed for acoustic features, with the idea that mild traumatic brain injuries and concussions have an impact on things like the pitch or the fundamental frequencies of the voice. That tablet-based test is meant as a first line of defense. So we identify signs of potential concussions, and then the athletes are referred to a medical team for further examinations. So we hope with these tests to collect a significant amount of data that we can analyze for ringside or sideline detection of concussions, and we also hope in the future to be able to expand these kind of tests to other diseases and health issues.
Wouldn't it be funny if you missed him the whole iPad when he was like pointing? It would just send him to the hospital. So we are creating a concussion app, and concussions happen all the time. What other sports other than boxing, skateboarding, and snowboarding might we see concussions? Football. Lacrosse, exactly. Anyone play lacrosse this season?
Yes.
Has there been a concussion this season?
Yeah.
Ryan, you?
Yeah.
Oh, great. Perfect. Now, Ryan, what factors went into diagnosing your concussion?
Like my hand-eye coordination, my balance, like remembering things.
Yes. And in fact, we're going to be discussing those factors today. So actually, Ryan, there are like 20 or 30 different factors that go into diagnosing a concussion. And it was a human that diagnosed your concussion, right? Not a program. Now imagine, folks, that you didn't have a doctor right then and there, or a trainer right then and there, able to diagnose someone's concussion. And this kid, like Ryan, wants to go back and play again. Was it just a normal hit, or was it a concussive hit? We're going to write an app to help coaches, help athletic trainers diagnose a concussion. So here we go. We're going to look at 4 factors. Vomiting, nausea. Did you have that, Ryan?
I have not.
Okay. Balance problems, clumsiness, drowsy, being dazed, and then memory loss before and after the event. Did you have any memory loss?
No.
I don't remember. All right. So we're going to look at those 4 factors, and here we go. Look at person 1, 2, and 3. I'm going to hand this out. You are Dr. Jayla Brown, MD, or Dr. Edwig, Dr. N, Dr. Baker Johnson, that sounds pretty good. Dr. Gambra, athletic trainer to the San Antonio Spurs.
Nice.
The Spurs are going to be the Lakers, right?
Yeah.
You said yes or no? You don't think so?
I hope so.
I think so. Aren't they 1-1 now? 2-0, yeah. 2-0. You're Dr. Tariq Brown, and the star player just came up to you and says, Doc, I just got hit. I'm pretty banged up, but I want to go back in. Coach told me to go see you. And so, I want you guys to decide, for each of these 3 athletes, yes or no? Do they get to go back in and play? Yes or no? Just read the descriptions and say yes or no. That's it. Whether Y or N. And this is your diagnosis for now. All right, now go ahead and discuss with someone near you, yes or no, and come to some kind of consensus. What did you say the first one? What did you say about first one? You said no as well? Okay, why don't you guys discuss the other ones? Right? You guys agree about person 1? Say yes. Go back in. Person 2, go back in.
We're not. That's the one where. This vomit. I mean, we could ask this about it. Does vomit really affect the?
Yeah, it is a factor. Yeah, but we need to talk about vomit, Cameron. That's a good question. Folks, person number 1, raise your hand if you said yes, you may play. Person number 2, yes, you may play. Person number 3, yes, you may play. Not a hand was raised. All right. So, I guess we're done, right? Program done? Yeah?
We're done.
That's it? That's it. We're done.
Figure out.
Well, yeah,
How
just,
is the computer going to know when they're involved?
now you say a little bit louder.
How is the computer going to know if they're involved?
How does the computer know about the vomit? Okay. In fact, how does the computer know about anything? Because a computer can't use words. What does a computer use?
Numbers.
Numbers. And sensors. Very good, Cameron, sensors. What if we took a picture of the vomit and the computer analyzed the vomit for how much it was? Good idea? Right, Allison? We're going to do something a little different. Wait on that vomit question. But you guys are right. How do we compute a rating? Why do we need to compute a rating? 0 to 100. Why? Say it loud.
In order to judge whether they're okay to go or they have to stay.
Yes, and even if they have to go immediately to the hospital, right? And so we're going to compute a rating 0 to 100. Remember that, Ryan. And we're going to need numbers, just like someone said. So, here are the steps in developing an algorithm. Tariq, can you read number 1?
Identify factors, variables.
Did we do that?
Yeah.
Give me one factor.
Vomit.
And give me a variable for vomiting. To represent vomiting.
0 to 100.
Okay, well those are values that we could use for vomit.
Chunk.
That's a value, chunks. But sorry, let me be more specific. Give me the name of a variable to represent vomit. What would you call it? B is a good letter. Number 2. Olive, can you read that? Sadesi, do we have numbers yet for vomiting and for balance and all that? No, so we need that. And then we're going to need to express a relationship, right, Edwin? Using an equation to represent the relationship among these 4 factors. Then we're going to create an algorithm and then code the algorithm. So, here we go. I have lots of numbers. 0's best, 10's worst, meaning the lower the score, the what? The better, meaning you don't have a concussion. 10 being the worst. So, go ahead and rate all the factors on a scale of 0 to 10 real quick. This is called quantification. we are applying a number to the description. A computer has to use numbers. So we're quantifying each description. Cameron brought up a good point about the sensor. While you guys are writing up the numbers, Cameron, you want to talk about that sensor thing again?
Computers use sensors to input data.
Computers use sensors to input data. Tom, what do you think about that? Anything to add about that? Computers use sensors to input data. How would that be useful here? It could analyze what it gets from the sensor and change it into numbers. Mika, of those 4 factors, which one is the most measurable by a sensor?
I'd say memory.
How so?
You can test it.
How could it test it?
You could test it by giving you numbers and then see if you remembered it.
Very good. And then what would you calculate after that?
The accuracy.
The accuracy. Very good. Thank you. What was your question? Okay, add on. Okay, say it louder, Saker.
They can also get their response rate to see how fast they can answer.
Response rate. Very good, guys. So we're going to create a simple app today. We're going to input all the data ourselves. But know that these guys are right. We really use sensors. So if you're going to rate vomit yourself and not have a sensor do it, how in the world do we rate vomit? Any ideas? How do we rate vomit? Chunks, non, spit, blood? Alexis?
Like the amount and the consistency.
The amount and the consistency. What do you guys think about that?
Yeah, that's
Cameron, you think that's good? Olive, you had your hand raised? They would weigh the vomit.
You're gonna do that for
That sounds yummy, guys.
What?
How you rate vomit? Now, Brian didn't vomit, but if you did, maybe we could just scoop it up and measure it using a graduated cylinder. Aha! Just pour it in there, right? And then if it fills more than one graduated cylinder, we can another one. And another one. You know what I mean? Chunks and all. Hopefully he didn't eat spaghetti that day. All right, so this number right here represents the amount of vomit in milliliters. 300 milliliters is about a Coke can. Coke can's about 330 milliliters.
No.
So if you get greater than or equal to 300, what do I rate the vomit? Is that bad or good? Bad. More vomit, worse the rating, which is a 10, the worst rating there is. Even if there's 600 milliliters, you rate it as a 10. What kind of algorithmic instruction is this?
Selection.
Selection. Very good, Mika. It says selection up there, right? Yes, that's right. Very good. So what other algorithmic instructions are we going to have in our program? Iteration. Sequence. Okay, here we go. Do all the factors have the same importance? Are they all the same? Vomit, memory? Memory loss?
No.
Tariq says no. Tony, what do you say? You're going to say it loud, Tony.
I said no, we can put vomit just for being hard instead of
You could vomit just for being hit hard? Okay. So he says vomit is the most important factor? No? Tony says memory is the most important factor. Let's find out what you guys think. Go ahead and rank them 1, 2, 3, 4. Just write down numbers. Next to the most important to the least important. This is a key step, ladies and gentlemen. Now we are using numbers to kind of express the relationship among these variables. The bigger the number, or the more important the factor, we'll use a bigger coefficient. And so if you rank balance number 1, you're going to apply a bigger coefficient to it than drowsiness or memory. Kind of like this. Anyone totally agree with me? Memory, balance, vomit, drowsy?
Balance is vomit, yeah.
Okay. So, look what I did. Don't copy my numbers. That's my view, my understanding is Dr. Democratic, because you guys are better doctors. Anyway, I gave memory and balance a coefficient of 3. Natalie, you said coefficient, right? Now, what does that mean about my understanding of memory and balance together? Like related to one another? If I gave them both a 3, what am I saying about their importance? Natalie, say louder.
They're both equally important.
Natalie, what do you think about that? So I gave it a 3 for each. Let's say I thought memory was the only thing that was important. What number would I give it?
10.
Well, folks, let me give you a clue. All of them have to add up to 10. So if I thought memory was the only thing important, Mika, what would I apply to it?
10.
And then what would I apply to the other ones?
0.
That's right. So mathematically, Mika,
Do I get a duck?
how? You get a duck. A rubber duck. Yes. So, Mika, if I put a 10 to memory and put zeros here, what happens mathematically, Mika?
The only thing that matters is memory.
Mathematically, and then that's an expression of a relationship that I understand among those 4 factors. So, real quick, there's a question for everyone. If I thought that everything was equal, this is a hard question. If I thought that everything was equal, what coefficient would I apply to each one? So that's how'd you get that number?
10 divided by 4.
Say louder.
10 divided by 4.
10 divided by 4. All right. But we don't think that, do we? Go ahead and give a coefficient to each factor. The biggest coefficient obviously goes to factor number 1. Go ahead and write down a coefficient next to each one. Those are coefficients right there. Okay. So which one do you think is the most important? Can you apply that? So you have to 10? Good job. All right, so we're almost there. Tariq, what did you apply to your number 1 factor? So you just, what number?
3.
And what was your number 1 factor?
3.
What was it? The name of the factor?
Oh, number 1.
What was the name of the factor?
Oh, memory.
Memory, thank you. Okay. Nora, what was your number 1 factor?
Memory,
And what coefficient did you give it?
3.
And what was your number 2?
Vomit,
What'd you give it?
3.
And so you went 3, 3, 2, 2?
Yeah.
Okay. Tony, did you go 3, 3, 2, 2, or did you do something different? 4, 3, 2, 1. All right. You can do many things. In the end, though, we need an equation to sum it all up. And so here we go, folks. Take your ratings for person number 3. The one that everyone agreed should stay out, right? Take your ratings for number 3. By the way, these aren't the ratings for number 3. These are just sample numbers. Take your ratings for number 3, person number 3. Multiply them by the weights. Notice these are different weights. By the way, if this is 2, 2, and 2, what am I saying about drowsiness, balance, and memory?
You feel like they're,
That they have the same importance. And I use numbers to represent that. Very good. Go ahead and get totals for each category. Nice one. That's good. Let's say possible.
I was supposed to say.
All right, let's take a look at Alexis here. Okay, what were your weights for your different factors?
It was 4, 3, 2.
Memory is 4, balance is 3, balance is 2, drowsy is 1, right? And so, what was your total rating for person 3?
61.
Go ahead and calculate person 2 as well. Because person 2 you said should go back in, right? So in the end, if person 3 you said should not go in, and person 2 you said should go in, should person 3 or person 2 have the higher concussion rating? Person 3. Go ahead and calculate person 2 real quick and see if that works out. We're testing our algorithm now. We're almost ready to go to the computer and obviously code this. So what'd you get in the end? And so, Tony, when we get the 4 factors and the totals for each factor, what do we need to do with those numbers at the end? Why do we add them up? A certain number will be like the limit or the rating for concussion. The question is a deep question. I'm going to ask the whole class. Folks, it's an assumption that we add them up, isn't it? But Nora, Alex Dang, Hamdi, and everyone else, why is it significant that we add them up? This is what I mean. If I subtracted drowsiness, well, how would that affect the relationship between drowsiness and the overall concussion rating if I subtracted drowsiness? Obviously here I add them all up and I get a number. What if I subtracted drowsiness? What would that mean? What am I saying about drowsiness then and concussions? Say that louder, Cameron. And unfortunately that's not the case, right? It's like saying the more memory loss you have, the better. The lower your concussion rating, which is obviously not true. And so we add stuff and subtract stuff to represent relationships among variables. And so we're going to create an app that might look like this. Look at that pretty background, some boxes. Does this look familiar?
Yeah.
Good. Use a previous program to help you. Now, what do we need to do now is take out our clock buddy sheets. You might use the same one yesterday, you might use something different. We'll see. Take out your clock buddy sheet.
What do you use 16? What do you use 12?
All right. So, before I pick out the clock buddy, you guys start pair programming this app. Clock buddy sheet doing? Let's loop back to the warm-up. Take a look at the warm-up. Not who should be able to play. Keep that. By the way, is the driver or the navigator, when we're pair programming, going to be using this?
Navigator.
The navigator, because this is like a what? A help sheet, a map for a navigator. Take a look at the warm-up. Now, does the warm-up make sense?
Yes.
What's going on with the warm-up? Let me... Mika, you already got a rubber ducky, but if you can help someone else out, pick someone, Mika. Senku. So how does this relate to what we're doing today?
We're going to be creating an equation to judge whether a person has a severe concussion.
We're going to be creating an equation to rate the severity of concussion. That's what Senku said. So Elizabeth, what does V stand for? And B? Tamia, D? And Julian, M? Memory. And Nora, what am I saying about memory here in relation to all the other variables? Say it again.
Memory is more important.
Nora said memory is more important. And Tariq, how do we know that memory is the most important? Has the highest what? What's that word again? Starts with a C. Coefficient. Tariq, Dr. Tariq Brown. All right. So here we go, folks. Where you get to pair programming here. You have your clock base sheet out. Cameron, pick a number. Subtract 2. He said 3. In fact, I'll just take 3 seconds. All right. So hold on. Get with your 3 o'clock buddy. Pick who's driving and navigating. Send the navigators to me. Send the navigators to me. Drivers, you log in. Navigators, come to me right now. Let's run. What do you think?
Shaking hands.
Can I get the navigators, please? Drivers, go ahead and log in. Navigators, come over.
I'm a partner, but he's not here.
Navigators, here we go. Folks, what are you going to have in your hand to help the drivers? Who should be able to play, right? Because what does this have on it? The weights, very good, Ryan. The weights. And then you're going to turn this into an equation, I guess? Well, along with the equation, you guys are going to need sequential instructions. One of these is not right. Which one is not right? The bottom one's not right. Why?
Enter before you even ask.
So you guys got to watch out for that, right? Help your drivers, okay? Second thing, selection. Do you remember this, the go-to statement?
Yes.
Now, the go-to statement here is not what I want to talk about. I'll talk about it in a sec. But the if statement is what I want to talk about. So you guys are going to have to ask the user whether they want to repeat. Remember that, all right? And that's the if statement, that's selection. And then lastly, iteration is when it goes back to the beginning and repeats the program. Use the label start, and then that's where you'll label start, right at the beginning. All right, navigators, go help your drivers get to work. Nick, how many minutes do we have of recording left?
6.
6 minutes? I'm gonna have to plug that in. So just keep on, don't pause it.
You said you have to use the iteration of 2 statements. And he said to make sure that we don't.
I'll focus on Nora and Alexis, I guess.
To make sure that
You know what? No, we'll stay over here. Tom, who's your
Oh, with the statements, we can't really read before we ask them if they're doing the go-to.
Yeah, just stay right there, Nick. Here. Turn around. Still recording?
Mm-hmm.
Mr. Dan, who's your partner? Dwayne, who's your partner? Okay, so you should work by yourself.
Oh wait, you said to use the.
Tom, what are the factors we're using? And what were your weights for the factors?
Memory had a weight of 4, vomit had a weight of 3, balance had a weight of 2, and drowsiness had a weight of 1.
Does it have to be 4, 3, 2, 1, Andy? What could it be? Whatever you want it to be, depending on what though? How important you rate it. Bonus points to people, to teams that show research backing up their weights. Tariq Brown, do you want some extra credit?
How do you do that?
Dr. Tariq Brown, do you want some extra credit? Yes. So, Dr. Tariq Brown, where would I go to research concussions? The internet, not a bad place. And more specifically, maybe some medical websites. And go ahead and figure out whether your weights are actually reflective of the reality of those 4 factors. So Tom, you picked 4, 3, 2, 1. Which one did you apply the 4 weight to? Memory. Why?
Because the brain handles all your thoughts and processes. So anything that has happened in your life is stored somewhere in your brain. Naturally, if your brain gets hurt, you would have memory problems.
That makes sense. So Tom, why 4 though? Why not 3? 9? What are you saying about memory mathematically?
Saying that it has the most importance out of the other factors, but the other factors still have some sort of importance towards whether there's a concussion or not.
Okay. All right. Thank you. Expressing relationships among variables. Seiko, what did you say for the most important factor?
I said it was
Memory. Okay. All right. And so what weight did you apply to memory?
I put 4.
4. Okay. All right.
That's not a weight, right?
All right. And I think we can move around now. Thank you. You can probably answer.
Weight of
You okay? It's next week. I mean, not next week. Next week.
Stipend included in some testing.
Wow. That's awesome.
We didn't know how to do the
Blows up. Very good. Ryan, what did you say was the most? What did you say, Ryan, was the most significant factor?
Memory.
Memory?
Yeah.
And so, what number did you apply to memory?
4.
And why did you apply 4?
Because it's the most important one. Although it's not that important, but if you can't remember what happened, it's like really bad.
Okay. So, Cameron, why do we use coefficients?
To give the value of one variable, to give one variable.
Then another one? Yep. Tony, you said memory too?
Yeah.
Tony, you play lacrosse, right? No? Baseball. Has anyone been hit by a baseball this season? Baseball players don't get many concussions, do they?
No, because we're running.
Are you allowed to charge, not charge, but are you allowed to run into the catcher like in the, like full blast? And you won't get...
I mean, if it's a close play.
And yeah, and you're going to run in, you're allowed to just go ahead and just...
Yeah, but if you're clearly like on our person match.
Yeah, sure, okay. And in lacrosse, you guys are just allowed to blow up people, right?
Yeah.
Totally blow up people.
Like, we're going to
Yeah. All right. Hey, did you guys win your series?
There was a time we could, like,
You have to. No, you have to decide whether you're going to do it as a graphics window input or a text window. You guys get it? You can make it a text window input. That's the easiest, right, guys?
Which one for graphics?
No.
For graphics window, there is no graphics window. You have to create a text box and all that kind of stuff. Yeah. And then put a little Y in it and all that. Just basic, you know what I'm saying, right, Alexis? You just do what you did with the other ones. Yeah. That's a good idea, Nora. Go ahead and switch driver and navigator. Switch driver and navigator. Make sure to say this as a different thing then. Alright guys. Yeah, don't just like do it. So that's the I got a good question here.
Mr.
Dr.
Najera, when is this due? Tomorrow?
Yes. Dr. Najera, what did you consider the most important factor? Sorry, I couldn't hear you. Memory. And so, how did you express mathematically that memory was the most important?
Theory. I would get it yet, but
A coefficient that's higher than the other ones?
So like 1 would be like 4, and 2 would be 3.
Oh, yeah. Okay, good. Feel free to use decimals too. All right. Very good.
We have like 1 minute on it.
Okay. So, folks, we're going to wrap up here in a sec. But on your warm-up, I want you to answer a question and then turn it in. Everyone, can I get your attention? You're going to turn in your warm-up. On the back of the warm-up, simply write, how do we express the relationship among the 4 variables mathematically? Answer that question. How do we express the relationship among the 4 variables mathematically? If you remember what Natalie said, it might just be one word, a one-word answer, or you could explain it in a sentence. How do we express the relationship among variables mathematically? Write that down. You can have your navigator take both of your warm-ups and stick it in the box. But when the bell rings, obviously we know that we're continuing on with this tomorrow. How much time do we have left on that, Nick?
It doesn't
Just
say.
stop?
Yeah.
Okay. But it's still recording now, right? Okay. So, reviewers, that is the end of the period, and what you saw is basically the introduction of a project, us getting to the lab practical portion, because I don't like them just listening to me the whole time. We do a lot of group work, and obviously tomorrow they're going to be working entirely on the lab together in their pairs, switching off driver and navigator as they go. And then we'll wrap it up in the end with a reflection and a discussion of what we learned. And the reflection is actually a project reflection that focuses them on like how the process works and what they learned about expression relationships. Bye.